Good afternoon, my dear students. So today in these sessions we are going to learn regarding the functions of springs. In the last class we have studied about the introductions of springs. The springs are flexible machine element which are used in the various machine component which deflect under the actions of applied load, and it regain original shape and size after the load is removed. But today in these sessions we are going to learn regarding the functions of spring. Generally we know very well spring is one type of the mechanical device so that can define the elastic machine element which deflect under the action of load and return its original shape and size when load is removed. In the first point, in the function of the springs, we have studied that spring is a one type of the mechanical device, or springs are one type of the flexible machine element which deflect under the action of applied load and return its original shape when load is removed. Let us see example. I'm taking example of the same spring. Okay, so this one is indicate that this is the above hook and this is below hook and this is number of turns of a coils, spring coils. If you apply the tensile load, due to what happened here, due to it will elongated, due to it will deflections. If you apply the tensile load from the both the side, the number of turns of a coils will be elongated. If I am removed, then what will happen here? It will occupy the same positions of a springs. Is it right? Again, the important function and applications of the springs we need to follow. The first functions of the springs are: the springs are used to absorb the shock and vibrations. Springs are used to absorb the shocks and vibrations. So such type of the springs are widely used in the car, railway buffer and buffer spring. In the elevator we are using such type of the spring. The second condition and second functions of the springs are: the springs are used to store the energy. I will give the example. When spring is loaded, this means that if we apply the some amount of load on the spring, then spring will absorb the energy. The spring, due to apply the load, it absorbs the energy and corresponding the deflection, and this spring can be released. If you release the load on the spring, when the deflection is allowed to vanish. Is it right? So this means that springs are mainly used to store the energy. So such type of the springs are used in the wall clock, as well as nowadays we are using in toys of a small baby, because the small baby playing along with the toys, in which we are using these springs. And the such type of the springs are mainly used in the movies camera, as well as sensor camera, as well as we are using in the circuit breaker, and we are using in the starter. If you start the motor, in which we are using the springs. Is it right? And third function of the springs are, the springs are used to measure the force. Which type of the force is acting on the spring? In the form of tensile load is acting on the spring or compressive load acting on the spring. We are measuring the force. For example, this spring is used in the weighing balance. Is it right? Like if you have the lorry, if you want to measure the weight of the unloading, okay, then you can measure with the help of weighing balance. What is the weight before loading and what is the load after the loading? Is it right? You can easily measure with the help of weighing balance. And the such type of these springs are widely used in the scales also. And the fourth functions of the springs are, these springs are used to apply the force and control the motion. This type of the springs are used to apply the force and control the motion. There are number of springs used for this purpose. For example, generally we are using cam and follower mechanism. We already studied in the laboratories. Okay, this cam and follower mechanism in which we are using the springs to maintain the contact between, this is cam and this is follower. This spring is maintain the contact between cams and follower. This springs is widely used in the clutches. We are using in the automobile. The springs used in the clutch to provide the required force to engage the clutch or disengage the clutch. In this application, this spring is used either to apply the force or either to control the motion on the any machine component. The next topics we are going to learn in the machine design is classification of the spring. So the use of springs is enormous, and hence based on the uses and shape we are classified the springs. The first one is helical spring. This helical spring is broadly classified into three types. How many types here? Helical springs is broadly classified into three types. The first one we can say as cylindrical spring. Second one we can say as conical spring. Third one we can say as valued spring. This cylindrical spring is broadly classified into two types. First one is compression spring. Second one is tension springs. Okay, these helical springs, again conical springs, is broadly classified into one type. We are using mostly compression spring in a conical spring. The valued spring mostly used compression spring. The conical spring and valued spring the mostly used compression spring. So helical springs are made in such a way that this spring wire is wound around the imaginary cylindrical or cone in the form of helix shape. Let us see the figure. This is compression helical spring, and this is tension helical springs. So let us see over here. I told you these helical springs are made in such way that the spring wire is wound around the imaginary cylindrical cone in the form of, how is it? In the form of helix, in the form of helix shape. Is it right? The first category is known as, what we can say, cylindrical helical spring. The first category is known as cylindrical spring or cylindrical helical spring, whereas the second category is known as conical and valued spring. So this type of the spring are manufactured based on the two conditions. The first one is compression spring, second one is tension spring. This compression spring we can say as open coil spring. This tension spring is also called as closed coil spring. What we can say here? Closed coil spring. If you see the figure, then you can easily understand. Okay, this is compression spring. This compression spring is also called as open coil spring. Okay, so in this spring, the distance between the two consecutive points, this is the first consecutive point, and this is first consecutive point, and this is second consecutive point. The distance between the two consecutive points, okay, so the distance between the two consecutive points, the turn more than helix, this helix angle is more than 10 degree. How is it here? This helix angle is more than 10 degree. Is it right? So these springs are used to resist the compression. These springs are used to resist the compression. This open coil spring used in automobile. This compression helical springs, this used in what we can say, in the motorcycle, as well as it is used in the internal combustion engine. Okay dear, again we are going to discuss about helical tension spring. So this helical tension springs also called as closed coil spring, because this one coil is closely related to each other, so for that reason it is called as closed coil spring. Is it right? In the closed coil helical spring, okay, this closed coil helical springs, so the distance between this is one spring and this is another spring. The distance between each turn or each coil is pretty less, or we can say as it is a lesser than 10 degree. It is lesser than 10 degree helix angle. So this type of the springs is used to resist the elongation. It's mainly used to resist the elongation, or it resists to twisting. It is used in a heavy duty applications. We are using the helical tension spring. Okay, again this next we are going to discuss regarding the leaf springs. Okay, so leaf springs, in which we are sometimes leaf spring also called as laminated flat strip springs. So let us see the figure, then you can easily understand of a leaf spring. This is our leaf spring figure. So it is arc shape. The leaf spring, it is a arc shape spring. So this spring is made of metal strip. So this leaf spring is made of metal strip. The one after another are held together. This is one spring, this is one spring, and this is another spring, are held together by means of nuts, bolt or clamp. Nuts, bolt or clamp. So it is fixed together by means of nut, bolt and clamp. So these leaf springs, it is widely used in a suspension system of a commercial vehicle such as we are using nowadays as in a bus, or we are using in a truck, or we are using in a lorries. Is it right? So the leaf spring is capable to withstand the maximum force in a small area. The maximum force they can withstand in a small area. So for that reason we are using the leaf spring. So it is this leaf spring, generally it is made of steel. Sometimes this leaf spring is made of graphite epoxy, or it is made of carbon epoxy material. Is it right? So this multi-leaf spring consists of this. Let's see over here. This is 1, 2, 3, 4, 5. So what we can say? Multi-leaf spring. What we can say here? Multi-leaf spring consists of series of flat plate. How is it here? Series of flat plate. Usually how is it? Semi-elliptical. How is it here? Semi-elliptical shape. So as shown in a figure. Okay. Then this flat plate called as, what we can say here? This flat plate we can say as leaves. What we can say here? This flat plate. This is first, second, third, fourth. What we can say here? We can say as leaves. These leaves are held together. These leaves are held together by means of U-bolt. By means of U-bolt and center clips. By means of U-bolt and center clips. Is it right? Then the longest leaves. This is the longest leaf, and this is one is the shortest leaf. This longest leaf is called as master leaf. What we can say here? This longest leaves we can say as master leaves. So these leaves are bent at the two ends. This is the first end and this is the second end. These master leaves are bent at the two ends. They form the, how is it? Spring's eyes. It is looking like a one eyes, and this is another large eyes. Okay. The springs are bent in such way that it is a forming of two eyes. Okay, dear. So on the multi-leaf springs, it is mainly subjected the bending stress or bending load is acting on these springs. So these multi-leaf springs we are widely used in the automobile, as well as we are used in the railroad suspension systems. We are using the leaf spring. Okay. Again, next one we are going to discuss about torsional springs. This torsional springs is broadly classified into two types. First one we can say as helical torsional springs, and fourth one we can say as spiral torsional spring. Okay. Then if you see the figure, then you can easily understand. Okay, this is our, how is it? Torsional spring. So torsional springs is one kind of closed coil spring. How is it here? It is one type of the closed coil helical spring. In this type of spring, when twisting occur, so when twisting occur, the spring store the energy inside it. When twisting is occur, the spring store the energy inside it. When twisting force lifted it, then it puts the actual position. If you release the load, it will occupy the same position of a spring. When twisted, if you twist the torsional spring, when it is twisted, then torque generated. When it's twisted, the torque is, see this figure, when it is twisted, then torque is generated at the opposite direction. Which direction? At the opposite direction of the twisting force, which help the spring back its actual shape. So generally the torsional springs can have the life cycle of 7 to 9 years. How many life cycle they have? They have 7 to 9 years. They have the life cycle of a torsional spring. So assume that 10,000 cycle at 4 cycle per day. So the torsional springs generally is used in a clips, as well as we are used in the garage, as well as we are using in our daily life, like mouse catcher. Is it right? We are using the torsional springs. And fourth one, we are going to discuss regarding the spring is disc spring, or we can say as bevel springs. Is it right? So disc spring is how's it is a one type of the conical shape of, see the figure, then you can easily understand. Okay, let us see over here. This spring is conical shape. How's it? This is one we can say as outer diameter, and this one we can say as inner diameter of the spring, and this is one we can say as the axis of the spring. So the disc, how's it? The disc spring is generally, how's it? Conical shape. How's it here? It is a conical shape. The washer is held together by means of bolt or tube. Okay, so this disc spring, which has the characteristics of a spring, it is a non-flat. It is a non-flat which non-flat conical shell. If you observe like this is looking like in this figure. This is a non-flat or conical shell spring, which are generally load axially. So the load is acting where? At the axial. Okay, here. This type of these springs can exert the constant pressure, but the disc spring can exert the constant pressure throughout the object, and also provide the high load where in the small area, high load in a small area. Then it can be used in a thermal expansion, as well as it can be used in a contraction. Wherever the contraction happen rapidly, we are using the disc spring. Okay, dear. So this is the conclusions of our topic. In the next topics, we are going to discuss about types of spring. So if you have the doubt, again I will repeat for this classification of spring. The helical springs is broadly classified into 3 types. First one is the cylindrical spring. The cylindrical springs is broadly classified into 2 types. The first one is compression spring, another one is the tension spring, and the conical springs is the mostly compression spring. The varied springs is mostly compression spring. And second one we already discussed about leaf spring. Sometimes we can say as laminated flat strip spring. And third one we are going to learn regarding the torsional springs. The torsional springs also broadly classified into 2 types. First one is the helical torsional spring, and second one is the spiral torsional spring, and fourth one is disc spring or bevel springs. Okay, This is the classifications of the springs. In the next topics, we are going to learn regarding the types of springs. So if you have the doubt regarding this class, please write down in the comment box, and please don't forget to subscribe my channel. Thank you, dear.